to another mini lecture. Today's topic is converting degrees to radians and radians to degrees. Two types are going to be looked at. Let's see, we are starting with trigonometry. The first thing with trigonometry is to learn about angles and how do we measure angles. The primary way of measuring angles is in terms of a circle. So, for example, when you have purchased a drill, you see an advertisement on it in terms of rounds per minute, meaning how fast the engine is going to turn. When you check your car, sometimes you pay attention to the same fact. You want to know how often does that circular shaft in your engine is turning. Same with bit of older devices, perhaps CD-ROMs and such. They would tell you the RPM. RPM would be round per minute. So round, circle, rotation, any terminology like that. If you're in car racing, they might call it a lap. So that's a primary unit of angles. So one circle. Well, what if you are traveling on a portion of a circle, a fraction of a circle, a small angle? How are we going to measure that? Well, of course, you can talk about 1/10 of a circle, or 1/100th of a circle, and so on. Well, from ancient times, there have been other units of measurements. The most famous of them is degrees. A circle is divided to 360 equal parts, and each of them is referred to as a degree, and the notation of that is a little circle on top of the number that you have. So a circle divided to 360. Now there are a lot of debates on why 360. Why not divide it by, say, 200 or 400 or 1000 or, I don't know, 59 pieces? Why 360? Two major suggestions. One is that 360 is the approximate number of days in a year. So people from ancient times were looking at the sky and following the stars and the sun, planets. They had a very accurate way of measuring things, and it made sense for them to have a concept of 1 degree. So 360, of course, that's not exactly equal to number of days in a year, but 360 is a very nice number. It's close to it. That brings us to the second reason that 360 was chosen, is that some ancient cultures used to count numbers in base 60, kind of like the way we use base 10. They had more elaborate way of measuring things, base 60, and again, why 60? What's so great about that number? It has lots of divisors. You notice that 10 just has 2 and 5. But if you look at the number like 12, the divisors are 1, 2, 3, 4, 6, 12. These are all divisors of 12. Go ahead, count the number of divisors of 360. These are numbers that can be divided evenly many different ways, and people who were interested in mathematics liked these type of numbers. So those are the two reasons, either astronomical or a love of numbers. One of them led to this idea of 360. Of course, influences your clocks and how you measure time, and etc., etc. Well, any other way of measuring angles? Yes, there is another one which is a bit odd at the beginning, which is the following. Take a string the size of your radius, so this is radius r. Lay the string on the side of the circle, so this is r. Connect that to the center And what this angle turns out to be is going to be called 1 radian. So 1 radian is an angle that is looking at a portion of the circle which is exact same size as the radius of the circle. Okay, this definition makes very good sense, because when you draw a circle, the only dimension you have that's relevant to your work is just the radius, and it's natural to ask, well, if I put that string on the circle itself, what would be the angle at the center? And that's called 1 radian. Well, in the previous lecture we learned that each circle has a circumference of 2 pi r, meaning if you repeat this, so let's color the circle with, here I put a green string here, and another say blue one, and again another green one, and then another blue one, and maybe you go through 6 of these things, and a little bit left over, you don't quite come back. So when you put that string on the circle and you turn around, how many of the pieces of that string do you need to come back? Well, what you need is exactly 2 pi, that is 6 of those strings. So what was 2 pi? 2 pi was 2 times 3.14, etc., 6.28. When you go around the circle, when you lay that string that's the same size as the radius, you go through 6 of them, and then a little bit left over, about a quarter of that string you still need. So it's 1 r, this is 2 r, this is 3 r, say 4 r, 5 r, 6 r, and this becomes 6.28 r. What is that really? Is 2 pi r. So a circle is 2 pi radians. That is this central angle here. If you want to cut a piece of pie or slice of pizza size of this angle, how many of them can you make? Well, you can make 6 whole ones and then some fraction left over. And how do you exactly measure that? It's going to be 6.28, etc. That's 6.28 radians. Well, is that the end of it? Well, some people a few years back objected to this number 360. They thought it's kind of an arbitrary number, and they suggested another one. And these are the people who like the matrix system. They say, okay, we agree with everybody that this right angle is an important angle. So let's take that, and instead of dividing it to 90 degrees, we are going to divide it to 100 grads. So when you go around the circle, you have 400 grads. As if you didn't have enough, there's another one. Why did I bring it up? The topic doesn't show up in your exercises here. The only things that you're going to see in the exercises are just these two. But you definitely need to understand how to measure, of course, a whole circle, because that's in practice that you see that just as often as you see degrees. This one shows up on your calculators, but doesn't show up here in Alex software. In most calculator, there is a button or there is a mode that you reach by clicking here and there, and that button has a labeling of DRG. DRG, of course, this is D, and this is R, and this is G. Depending on which one of these units you want to measure something in, you press that button, and somewhere on the corner of the display of your calculator, maybe up here, maybe up here or somewhere, you see a little notation reminding you what unit you are working on. So if you change that instead of R it's going to show a D or show a G and so on, and you cycle through the choices with this DRG. Okay, so that was a long introduction to something that you probably already know. How do we convert? Well, we convert by using this formula that we have here, 360 degrees equal to 2 pi radians. So if I have degrees and I want to measure in radians, what do? 495 degrees. One way to ask yourself is, well, how many circles is that? You divide by 360 to see how many circles is that. Notice that degrees up there and also down here. And then you multiply by 2 pi, because each circle is 2 pi radians. So you divide 495 by 360 to see how many circles you're dealing with. You multiply each circle by 2 pi to see how many radians you're dealing with. And then sometimes perhaps you want to simplify this. Maybe sometimes there is no point in simplification. So for example here, let's write it. Let's write the numbers. 2 times 495 over 360. In this problem the calculator is not provided and you are supposed to do this thing by hand. So we notice numerator and denominator are divisible by 9. So I say divide by 9, so it becomes 40. This is easy. Here I have 55, is that right? 55, that's good. Now I divide by 2, so that's 20. I divide by 5, 11, and 4, so it becomes 11 pi over 4. It's not asking you to simplify, but it's a good exercise for you to do it. So when you want to enter, you probably could have entered it just like this and get away with it, but for your own edification perhaps you want to practice a bit of simplification. How about the other type of exercise? We are going from radians to degrees. So the angle is minus 7 pi over 2. How many degrees is that? In general, what do? Again, you convert to circles. How many circles is that? Divide by 2 pi to see how many circles that is. Then multiply by 360 because each circle is 360 degrees. You want to simplify this thing. So let's write all the numbers. Minus 7. Well, obviously pi's cancel. 360 over 4. Of course, 4 and 360 becomes 90. 7 times 90, don't forget minus 360 degrees. Perhaps you could have been faster by thinking about it in the following way. When we say 360 degrees is 2 pi radians, you might always memorize that, well, 180 degrees is pi radians. And 90 degrees is pi over 2 radians. So these are things that happen often enough that you want to have it in the back of your mind. So this is pi over 2, that's 90 degrees. 7 of them is 630 degrees. And since this was negative to begin with, then of course we have to be careful that this is also negative. Same type of an exercise here. Let me see, you can be quick. What is pi over 4? You remember pi over 4? Let's extend this list. Pi over 2 is 90 degrees. Pi over 4, of course, then is 45 degrees. How many of pi over 4s? 13 of pi over 4s. You always want to draw a picture and remind yourself of what are you dealing with. So pi over 4 is that. You're dealing with 13 of them. So 1, 2, 3, 4, 5, 6, 7, 8. That's 8 slices of this pizza, and then we keep going So here was 8, 9, 10, 11, 12, 13. So we have gone one whole circle. We go one whole circle and then continue winding all the way up here. So that's the angle that we are dealing with. Now formally 13 pi over 4, you divide by 2 pi, multiply by 360, and then you'll be all done. Pi's always cancel. So you have 13 times 360 over 4 times 2. So 4 times 2 is 8. Divide by that is 45. You are multiplying 13 with 45. So 45 times 13. If I'm not mistaken, 585, and so on. This one asking you the other way, from radians, from degrees to radians. So minus 600 degrees. You want to notice that numerator denominator have the same unit. Then converting to radians, we said that's 2 pi. So then you simplify that, or not to simplify it, either way. So it doesn't have to be always nice numbers. So in this case, you're just having some arbitrary angles, totally arbitrary. It says round your answers to the nearest hundredth. So the idea that it's asking you minus 306.7 degrees, so some strange number, divide by 360 degrees times 2 pi. You notice the notation of pi is not here anymore. So this pi, you want to also use your calculator pi, 3.14. And then give the answer as a decimal, rounded to the nearest 100th. Same issue here is minus 122 degrees. You multiply by 2 pi over 360. Again, pi that you want to use here is the decimal equivalent of it. You don't want to leave it as a pi. The notation of pi is not there, and it just wants a decimal answer. Now, when you go to your physics classes this semester or next semester, they are going to be a little bit fussier about this issue, and for good reasons. When you want to do conversions and do arithmetic with numbers, you cannot generate too many digits at the output if your input wasn't given to you with those many digits. What does that mean? You don't want to give a very precise answer to a very rough question. So for example, this problem, this angle is given to 1 decimal place, but he is asking you to give the answer to 2 decimal places. Maybe he could have asked you to give the answer to 5 decimal places. Would that number be meaningful? Well, that's what you are going to be listening to in a physics lecture, that you have to be clear about how precise your input is. So when you write to 1 digit, the implication, the convention is that that is the best you could do. That's the best that you have. You don't know what the next number is. If you don't know what the next number is, you have to be careful that when you are producing an answer, you don't project too much precision in it. And so you are going to learn about number of significant digits in your physics classes. We don't deal with that in math classes, but it's something that I just wanted to bring up. So to summarize, we have at least 4 ways of measuring an angle. in terms of how many circles it is. So circle, rotation, round, what other words can you come up with? I'm sure you can come up with variety of words like that. All of them get to be used. One circle is 360 degrees, that's the same as 2 pi radians and the same as 400 grads. You use that for conversion. You always be careful that on your calculator there is a D or G button, and somewhere in the corner of your calculator is going to show which one of these three you have chosen, and your calculation of angles will be subject to that unit. What else we learned? We learned that to convert from radians to degrees, you divide by 2 pi, and 2 pi by 360. The other way around, if you have degrees, you want to convert to radians, you divide by 360 and multiply by 2 pi. Okay, so until next time, good luck.